Ladies and gentlemen, welcome. This is chapter 4, and in this chapter we are focusing on quadratic functions. In this particular section and series of videos, we're going to be able to create a table to graph a quadratic function. We'll also be able to graph a quadratic function that is in standard form, where we use some formulas to make that happen. So what is a quadratic function? Well, a quadratic function is any function that can be written in this form. Y equals ax squared plus bx plus c. This first term you see right here, we'll call it a quadratic term, is the term that really makes this thing a quadratic function. Notice that it is being squared. If we were to ignore this and just look at the bx plus c, well, that's a line, right? That's mx plus b, right? So this addition of a squared term is what makes it quadratic. And quadratic functions will behave differently than lines will, okay? So the shape that this graph creates, instead of a straight line, it creates this thing called a parabola. And a parabola is kind of a U-ish shaped graph that's either facing up or facing down. This first one, if it's facing up, we call that concave up. If it's facing down, we call that concave down, right? Concavity is the curve. So this is like saying the curve is up, right? The concavity, or the curve is down. The concavity is facing down, all right? So this is the type of graph that a quadratic squared function here creates. So why does it do that? Well, let's create a table to see what happens here. So I just chose some numbers over here, -4, -2, 0, 2, 4. Basically arbitrarily, I wanted to keep them around a little bit on the negative side, a little bit on the positive. I did want to keep it near the vertex, and we'll discuss how we know where that is a little bit later. So I'm just going to plug these numbers in, right? I have the x equal to -4, so I'm going to replace that in my equation here and then solve. So this is -1/2 times 16 plus 3, which is -8 plus 3, or -5. So when I plug in -4, I get -5. So there's my point right here. Okay. And then I'll plug in -2. Y equals -1/2 times -2 squared plus 3, which is -1/2 times 4 plus 3, or -2 plus 3, which is 1. So I've got -2, 1 right here. And plugging in 0, that's -1/2 times 0 squared plus 3. Well, that's just 3, right? So there's 3. That's going to go there. So notice how it's kind of curving up right now. Notice that it's not increasing at the same rate. Okay, this is not a line. It will not create straight lines. It creates a curve. Let's do these last two here. -1/2 times 2 squared plus 3. Well, I notice that 2 squared and -2 squared are the same, which means that this is going to end up being the same value as my other one, right? Because 2 times 2 is 4. -2 times -2 is 4. That means that this is going to be y equals 1. And when I plug in 4, the same thing's going to happen. Look, -4 times -4 is 16. 4 times 4 is also 16. So when I multiply when I plug in 4 here, I'm going to get 16 times -1/2. I'm going to get that same thing. -8 plus 3, giving me -5. So look at what happened. This is 2, 1. This is 4, -5. Notice how after it reached the peak up here, it starts to curve down in roughly the same manner that it curved up, right? Actually, it curved up in the exact same manner. This point right here, the very peak, it's called a maxima. or maximum, also known as the vertex. Okay. Once we get to this point, when I plug in the opposite version, the negative or the positive version of the same number, they end up being symmetrical. So the reason why these formulas, there's only one m in symmetrical, I think. I don't remember. The reason why these end up being the same on both sides is because when you square a number, a negative times a negative becomes a positive. So if your vertex is right in the middle here, plugging in the same number on the opposite side is going to make it curve to the same point. So this is what happens with parabolas and why they don't continuously just increase at the same rate. Because when you plug in that symmetrical x value, it makes this, it gives us the exact same output. Notice that for every output, we've got two different inputs, right? Okay, so I've got a practice one to show for you to do on your own on the next thing. Go back to Canvas, do that on your notes, and then we'll see you in the next video.